you have to take one part of them.
老师，这个是 half BC。
half BCA.
Uh-huh.
BCA. So it's wrong. It's wrong.
这个是 BC。
哎 part. 6 travel 2 1 why
老师，这个是 12。
is 12 the 12 where is 6 you have take all the red part answer that.
老师 the question said only BC.
No, yes, only BC, but every time when count a member, you have to take the whole right part, the whole left part. So you're missing the whole part. The whole.
So老师 if you take whole part, so 6 for
Yeah.
that would be for BC.
It's for BC. It's BC. It's BC. Get it. Fn. So Fn equal 18. 6 14 6 8 4
8.
Yes, sir.
I was because the question said BC. I was thinking only here.
No.
Oh shit.
Every time when you want to find the entire force, make a cut, take the entire part, the entire left part or the entire right part. The whole part.
Whole part.
Yes.
Plus, if you are looking for BD, you cut only here.
BD, yeah.
CD,
BD, yeah.
CD, you cut.
CD, cut here. The whole left part just here. 6. So, 6.
Is it minus 6 or 6?
Yeah.
Minus 6 or 6?
Yeah. Fn minus 6 equals 0. Fn equals 6.
Oh. When going to the right is negative? It's positive.
Yeah. So it's positive, right?
The other side is positive.
BC is negative, right? This is positive. Fn is positive.
This one is positive.
Yeah.
Opposite direction.
Intention is positive.
Yeah.
Okay. Class begin. Okay, class begin. Because there are lots of students now. At first, let's get a review. Okay, from the beginning, this semester, we learned what is well, as we study and support in at first I introduce the basic knowledge of statics. Can you remember it? Support all kinds of support, some kinds of how to do the reactions. This semester I introduced it. How to get a free body diagram. How to get a free body diagram. It's not how to find the reactions concurrent for concurrent force system, how to find the reactions. It's a concurrent force system for complete forces. For complete concurrent forces, there are two equations. We can get two unknown forces. There's a general complete force system. Complete force system. We can find the addition. Three equations. Just two equations. We can forget it. Then after I introduced this statistics, I introduced how to get Fn into the force, how to get the method of section. The method of section. How to find the Fn. Then I introduce X for X load member. How to find the Fn? How to find the sigma equal F over A? It's the stress on the cross section. It's the normal stress on the cross section. We also introduce the stress. How to find it on the oblique surface. The sigma alpha, it means it's sigma alpha, it's tau alpha. Sigma alpha is sigma cosine square alpha. Is sigma is this normal stress on the cross section. Tau alpha is half sigma sin 2 alpha. Can you remember it? Then I introduced how to get the deformation of a axial load member. Theta L equal F L EF. Theta L equal F L EF. Then we introduce the shell deformation. For a bolt, F and for a bolt, yes or no? The self stress is F OA. Yes or no? For a bolt, sigma BS bearing stress is ABS. Yes or no? For a second cylinder bolt, AB, suppose it's T, it's D, ABS is D times T, the area. For the shear stress, the area is half D square. Then I introduced the definition of the string, normal string equal is the share string equal half pi times theta prime. Can you remember? Can you remember? And then last lecture, I introduced the property of the materials. What is elastic limiter? What is proportional limiter? What is yield limiter? What is ultimate limiter? I review this is to tell this student they can come here. If they don't know, they can ask you to know this thing. Today, today we are going to study chapter 10, torsion. Didn't they? Actually, we learned a lot of, we have learned a lot of things. If you really know it, okay. Actually, in mechanics of materials, we focus on single member, single cylinder member. For mechanics of materials, we focus on cylinder, one member with cylinder. Cylinder member. We don't care block and plate in mechanics of materials because for the block and the plate, they belong to elastic mechanics. If a structure, there are a lot of members, it belongs to structure mechanics. We will learn it next semester. Yeah, so this semester in mechanics materials, we just focus on one cylinder member. For one cylinder member, there are three kinds of deformation. One is axial loading. The other one is shear deformation. We finished two kinds of deformation. Today, we are going to study torsion. Distortion. Yes, sir. And in the future, the fourth deformation is bending. So today we focus on torsion. If we know how to find the stress for the shaft, for the shaft, it means we can define, we can determine the member is safety or not. And then if the deformation is too large, it can't work properly. When a shaft want to work just on the shaft, the two ends, there is a rotation. This cross section will rotate with respect to the other end. Yes, there is a rotation between the two ends. The angle is the deformation of the shaft. Understand? Torsion. This end will rotate with respect to this end. Torsion is the first of an object due to an applied torque. Torque is the moment that tends to toss the member about its longitudinal axis. Actually, this is some example for shaft. Is a shaft. Is a shaft. Is a torque. Is torque. When we express a torque, we have two ways. One is the direction. Is the direction of the torque. This if we draw like this, it means the core direction. The meaning of same. We have two ways to denote it. One is an error, one is a band error. Only is the target. Is the target. We can draw it like this. It's also a target. They express the same thing. And that we have two ways to draw a moment. Is the direction, is the curve direction, CURL, curve direction. They are the same thing. How to find the stress for a shaft? We don't know. So at first we have, when we want to find this stress, this stress for a shaft, at first we do experiment. It means for a shaft, at first, suppose it's a shaft. That's now at first we draw some end line. Every curve means a cross section. Then draw some line longitudinal, straight line. After then, we exert to talk on it. To talk on it, on the shaft. On the shaft. We will find the deformation like this. Soft. Like this. Suppose the shadow plane, we consider it will move to a new place, a new location. Yes, sir. This is deformed plane, undeformed plane. The angle is the deformation of the shaft. Look at this figure. We can get a small square. Is not deformation, not deformed. Of the shaft deformation deform, the square change to this figure. We will know. Suppose I show it. In not clear. Wait. T. The land will move on another place. But we call the deformation of the shaft. In a half line. Before deformation, the angle is a right angle. After deformation, the angle is not a right angle. What is this? Shear strain. How to define shear strain? Can you remember it? The change of the right angle. Yes, so this angle is shear strain for this point. Yes, okay. So L times gamma is low phi gamma. This angle is the shear strain. We will know after. When we do the experiment, we will find the shaft bone expansion, not a contraction. Yeah, no expansion, no contraction. Just rotate, just rotate. Then the before deformation, the cross section is a plane. Yes, of the deformation, the cross section is the same plane. Yeah, a plane. Plane is a plane. And of the deformation is also a plane. Is also a cross section. But it's for this. Is for the cycle rod. If the if the rod is not a cycle is not a cycle rod. For example, if it is a rectangle rod, if the torque act on it, this line of the deformation is not a straight line. Of the deformation, it will become a curve. But just for the sake of rod, the line means a cross section of the deformation is also means a cross section. But for this kind of rod, is not a cross section. They are different. So we just can find the shaft for the. We just can find the shear stress for thick rod. We can't find the shear stress in this kind of member if the cross section is not thick. Understand? Because we get the formula based on the experiment. Understand? Because based on the experiment, we can find that LR is low phi. LR is low phi. It means gamma is low phi over T. It's low. It's low phi is the length of this side. Gamma L is also the length of the side. So they must be equal. Yeah, so we can get it we can get the shear strain. Rho. The distance, radius, is the distance from the point to the centroid of the cross section. Understand? So we know suppose is the cross section O prime P prime. So rho of O rho of B are different. Yes or not? Because rho is the distance from point to the centroid. Yeah. So we will know from the formula. We will know the shear strain is proportional to the distance from the point to the centroid. So, understand? It means the maximum value of the shear strain is on the surface of the shaft. Shear strain, it means shear strain at this point is more than this point. Yes or no? Is proportional to the distance. Understand? Understand it?
The one on the circumference,
Ah,
the shear strain,
The-
circumference, circle, it's higher than the one inside.
is hair on the outside. Yes, yes. It is small. At the same time, the shear strain is 0. Yes or no? The shear strain is proportional to angle of thrust. Also, is proportional to the angle of thrust and the radius. Rho actually is radius. Its max is shear maximum shear strain. C is the radius of the shaft. Phi is the deformation of the shaft. We just get it from experiment. If there is no experiment, you can't get it. So we do experiment and then from triangle from geometry we get this formula. One is C radius. C is the maximum value of rho. Is C is the distance is C for a given point in the shaft. The distance is rho. So C is the maximum value of rho. That's that. Got it? About what? We will derivation of a Gaussian formula. It means how to find the shear stress for shaft.
Yes. Actually, which one?
It's
is higher?
deformation.
Yes. At this angle, from this angle.
No, it's not deformation.
Always from the middle.
Okay, you go back. It means this. You didn't get the meaning of the mathematics. It means suppose before deformation is a line. After deformation, the line turn to here. Understand? So it's phi. It's phi. That's all. Come to apply. Understand? So you misunderstand. Then, well, I'm going to derive the formula how to get shear stress for a shaft. At first, let's consider the full circular shaft. We just care circular shaft. And we don't care any other shaft. Actually, in engineering practice, all the shafts are circular shaft. Almost of the 99.99% yes. A section perpendicular to the axis of the shaft can be passed at an arbitrary point C. It means we get a count. Yes, get a count. Because we know from the at first we is an experiment. Yes, is an experiment. The shaft don't expansion, not contraction. So there is no the length, and then the length of the shaft remains, don't change. The length don't change of the deformation. So if the length doesn't change, means what? It means it means on the cross section there is no normal stress. Because suppose there is a normal stress, the length will be changed. Because the length remains. So same. So we can assume on the cross section there is no normal stress. There are just the shear stress. Because it's shear stress. Shear stress maybe in this direction, maybe in this direction. We don't know. Oh, yes or no? We don't know. But because the shaft don't expansion, not contraction. If this stress is in this direction, we can resolve it in two components. This component will expand the cycle. Expand the cycle. Yes or no? So the shear stress can point in this direction. If tau is in this direction, the shaft will be expansion. Because there is a component. Let me draw it up. Suppose tau is in this direction. Yes or no? For this point, either for this point, they have the same angle. Yes or no? They have the same angle because it's the same. Yes or no? So you see that. So for every point, we can resolve it into its two components. This one, this one, and this one. Consider this component. This component will expand in not the cycle. This component. Consider because for the experiment, the cycle from the expansion. So T is not in this direction. Yes or no? Suppose it's in this direction, the component will pass through the point or pass through the centroid. It means the signal will be constriction. So T can in this direction. So because the theta, the shaft doesn't expansion and contraction, we can find the shear stress is perpendicular to its radius. As that, in this way, we determine the direction of the shear stress. Yes. If the shear stress is not perpendicular to the radius, the shaft will expansion will be expansion or constriction. There is no normal stress. If on the cross section have normal stress, normal stress is in this direction. Yes or no? If there is normal stress, the shaft will shorter or longer. Will be shorter or longer. Because the length doesn't change. It's based on the experiment. So we can get T because we know, suppose the torque for a given cross section is T. It's T. How to get T? Let's find the dA. How dA is the force, is the shear force acted on the small area. T is the resultant of the shear force. About is the resultant of the moment of the force of the shear force on dA. The moment of the shear force on dA about the centroid, the moment of the force is no, because the distance is no, the direction is this direction is perpendicular. Yes or no? Yes. So the moment of tau dA about the point about the centroid is no tau dA. In statics, I tell you, the moment is the force times the perpendicular distance. That's all. So the summation resultant of all the moment of the shear force is T. That's all. It's T. We know T lo G gamma lo. Do you know it? Sigma E epsilon Hawk's law. Hawk's law is Hawk's law. It's also Hawk's law. We know gamma law equal what? Gamma law equal y law L. Yes, sir. T law y law. Erase it. We will know how law equal G gamma law is y law L. Yes, sir. This is how law. Yes, sir. What is how law? Yeah, it's integration G y law square L E A. Yes, sir. Yeah. Is it red or not? It's a fact. Okay. We will find because G L phi is a constant, so G phi L integration no square E A. That's all. Okay. How to get this? How to get this formula? Is the balance is zero function. I get all the equation. No EQT is EQT no EQT gamma P 因此 gamma P应该嘞。哦，哎，I make a mistake. I make a mistake. 但是 make a mistake. It's we know gamma law equal where no it's no phi L no phi L 也是呢它 law equal G gamma law G equal tau law E A law. Yes or no? We get this new equation. How to get the tau law equal T law integration law square A? Where I want to get the formula. How to get it? And first 的补充几个问题套路 out here bring what out at first it means it's G low phi L. It's not. It means it's low G low phi L here equal G phi S G phi L square dA. Yes or no? Phi over L. Phi over L. Right? Phi over L is phi over L. Phi over L is gamma rho yes or no? Let's find let's do it phi over L. Look at it. Gamma rho over rho is phi L. Is phi L. Replace it. Yes or no? It's gamma rho. Yes or no? G no is tau no. 是吧 ？G gamma no is tau no. It's tau no. Yes or no? So tau no T is here. So tau no is T no over this one. Yes or no? So because this part they can't see. Oh yeah. How to do it? How to do with it? Just remember the result is enough. So if we replace this part, we define it as a pure inertial moment. Inertial pure polar moment of inertia. We call it of an area. Yes, this part. Yeah, we denote it by J. It means only set J equal rho square dA. That's enough. We can find tau rho equal G rho J. Because this part is dependent of load. Yeah. It's not relative to load. It's just geometry is just the geometry property of the cross section. That's that. So we can get the formula. We can get the formula. How to get the total? Is the shear stress? How to find the J? Yes or no? I will introduce it. How to find the J? How to find the J? Polar moment of inertia. J is the polar moment of inertia. How to find the J? J is the definition. Yes or no? Let's get a small a, or is a dA. dA is the theta. The distance, the radius is low. The distance is low. Distance is low. With d low is a band, is a the shadow part, the area dA is 2 pi rho times d rho. The integration is half pi c power 4. Can you find it? It's advanced mathematics. You know it. You can. She can. So if you don't know how to calculate, you just need to remember it. It's enough. For theta, the polar moment of inertia is half pi times radius power 4. It's okay. Because if you don't know how to calculate, it doesn't matter. Yeah. Actually, we just focus on the result. We don't focus if you know calculate it. Can see that if the shaft, the center part is empty, is hollow, because it's a hollow shaft, J will be this result. The result of J is here minus the inner part. Understand? Sometimes we know the shaft is a hollow shaft. Why we make a shaft as a hollow shaft? Because it's more safety. Why is more safety? Because J is greater, is go up. J is more than the software. Whole software, the J is more than this one. Understand? So let's get a review and introduce today. At first, for a software, how to find the shared address for a software? At first, we do experiment. Draw some line on the surface. Do experiment. After experiment, we find the shaft doesn't expansion, not contraction. The length doesn't change. It's not so. Because the length doesn't change, so we can assume there are no normal stress on cross section. Because the shaft doesn't expansion, not contraction, we can assume the shear stress is perpendicular. For every point, the shear stress is perpendicular to the radius. It's not after the experiment, we can derive the formula. How to get it? Because we know the geometry, we know shear stress, shear strain. We can get this. We can get it. It's not. It's shear strain equal no phi L. No is the distance from the point to the centroid. Phi is the angle deformation of the shaft. L is the length of the shaft. Then we know the shaft is balanced. So because the shaft is balanced, the torque is the resultant of the shear stress. It's for a small area, the force is tau dA. The moment of tau dA about the centroid is no tau dA. Integration over all cross section, we can get T. Because the shaft is balanced. Then we know tau Hawkes G gamma is Hawkes law. From the three relationship, from the three formula, we can get shear stress. Shear stress is T low J. Homologous is on the side, on the outside of the theta. It's not C is the maximum value of no. So if a shaft will break, the crack will appear on the surface of the shaft. Because the maximum shear force happened on the surface, outer surface. Then let's focus on J. J is the polar moment of inertia. We can get it here. We can get it. It's half pi C power 4. Then we can do exercises. Suppose here is an example of the way after I introduced the polyequilibrium for given cross section, the distribution of shear stress, we will know it. The shear stress, the distribution of the shear stress over the cross section is this. Suppose T is in this direction. Is tau max. Is tau max. For given line, it passes through the centroid. The distribution of the shear stress over the straight line is like this. Is centroid. The stress is proportional to the distance. It's low. One low is getting higher. The stress also getting higher. That's that. Is a distribution. Suppose is another. Okay. Suppose is an example. Look at it. Suppose copy it. Copy it. Suppose is inch. How to get the torque? How to get the torque? How to get the torque on the cross section? You think of it, okay? Let's take a break. Well, it's not a confident. It's okay. 真的是夏季。
Wait. I think I know why. You know why they can't see? The reflection of this light from here to here, the angle is more than yeah, the angle is more than the angle is more than the camera can only focus on just that side. Yeah. So we need the light this more data. Yeah.
Oh. Oh, how to delete it?
So we need that.
Oh. Make a mistake.
Can I?
Can what? Your handwriting is beautiful. What? Let's do exercises.
But now she's if it's dark like this.
If it's dark.
Yes, they can see.
Oh.
But if it's
Yeah, now they
can't see. So I wanted to change the thing from white to dark. So that even the PPT, I want the color of the PPT to be maybe gray. The background is gray. But the
depends
problem
on teacher. If you make it PPT,
this actually can I start?
Okay.
The start button is working.
You don't know how to restart it. Eh? It's turn off the power.
combination.
Where is the power?
Why did you the combination?
Thank you.